Today I've got a MacBook Pro with the M1 chip that came in for data recovery. According to the client, it just died one day. No lights, no signs of life at all. Let's run a quick diagnosis together and let's see what's going on with this guy. First, let's try powering it up with the charger. We'll test both ports one by one. Alright, let's try the top port first. We've got 5 volts, 0.9 amps. The USB tester doesn't switch to 20 volts. Now the bottom port, still 5 volts. Current is a little different and jumps to 0.46 amps, but still no 20 volts. Let's go back to the top port just to double check. Yep, exactly the same. The trackpad doesn't click either. Judging by the difference in current draw between the two ports, I'd say the issue is probably on the side where the current is lower. Could be a short somewhere. Let's open it up, pull out the logic board, and start digging deeper to find out what's going on. After removing the board, I want to test it separately to rule out any issues with external components like the screen, keyboard, or trackpad. I'm plugging in a good known USB-C connector and we'll test both ports again. Let's start with the lower port. Current draw changed a little, but it's about the same overall. Still no switch to 20 volts. We'll try the upper port next. Same story as before, 0.09 amps. So what we're gonna do next is, using a multimeter, I'll check all the main power lines for any shorts in a diode mode. After that, we'll take a closer look at the USB-C controllers and check their power rails as well. This line's good. This one too. No shorts. Readings look normal. Everything looks good here. Oh, seems here's the issue. We have low resistance. Second controller looks fine. Yep, about 80 millivolts in diode mode when it should be around 400. Let's pull up the schematic and see what that bad line actually is. Looks like it's the 3.3 volt LDO rail for the main USB-C controller. I'm going to remove that controller and see if the reading on that rail goes back to normal. I know the issue comes from the controller, not from any capacitor or passive component around it. The short on that line isn't a full short, it's not reading 0 ohms. That means part of the chip's internal structure is still there, but some transistor junctions inside have broken down, lowering the overall resistance. If the line were showing a perfect 0, I'd suspect a shorted capacitor and wouldn't touch any ICs at all. In this case, the resistance drop clearly points to internal damage inside the controller. Most of the time, the reason is a cheap third-party charger or cable. You can often underestimate how much accessories matter because on the outside, a $3 cable looks identical to the one that costs $50, but internally, the difference is huge. Let's clean the board and check the readings again without the faulty chip installed. Everything looks good here, 0.494 millivolts. Let's compare to the same rail on the other controller, and we're good. Now we're going to take an identical controller from a donor board and swap these chips. These chips can't be bought as new parts because they contain factory programmed firmware. The actual architecture behind Apple's boards is much more complex, but we won't go into those details now. What's important is that so-called new chips from China have a high chance of being non-functional or mismatched. That's why we only use original components taken from donor boards. Let's get this chip ready for replacement and install it. Let's check the resistance on all controller power lines once again. It may still be a little low because the board's warm. Once it cools down, it should get back to a normal value. This is exactly what I said. It's not a short. It's a temperature dependent resistance. The higher the temperature, the lower the resistance. So everything looks normal. And we can run the final test and see if we get 20 volts. So we'll plug in through the USB port, and we can see 20 volts. That's what we want to see. Let's test the second port. $20. Everything looks good. Now we'll partially reassemble, drop the board back in, connect all the flex cables, display, and battery, and we'll power on from the charger. All right, let's give it a shot. That's what we want to hear, the startup sound. Trackpad clicks, and we're booting. We can see the desktop. That is a very good sign. Now we'll test the second port. And everything is working. Startup chime, and we're booting. Now we'll wait for the client's passcode, and we can pull the data and create a full time machine backup. Thank you for watching. Here's some more interesting repair videos, and if you enjoyed, please consider subscribing. For all your data recovery needs, please head to the link in the description.